All right, guys, so we're continuing on with the 6B review. Just going back over this test review from Unit 6B. This is still Miss Adams here, so we're looking at problems 7 through 11. We're going to answer true or false. If the statement is false, we're going to provide a counterexample. So the product of two rational numbers is always rational. This is true. So if I'm doing something like, let's say 2 over 3, so 2/3 multiplied by 1/2, you're still going to get something along the lines of, let's see, that's 2 over 6, so that reduces to 1/3. That's still a fraction, which is a rational number. So yeah, we're good. All right, now we're going to look at the sum of a rational number and an irrational number is always a rational number. This is false. Sum is addition. If I say 2 plus pi, that's not rational. Plug it in your calculator. I'm going to say 2 plus pi. Oh, here's pi. Man, that just goes on forever. No repeating patterns. It's a gross decimal. It's not rational. Okay, so that's false. The sum of two rational numbers is always rational. Yes. This is true. 2 plus 3 is 5. 1/2 plus, let's see, 2/4, that's also going to give you the same thing as 1/2 plus 1/2. That's a whole number, that's 1. Even if I did something like 2/3 plus 1/6, 2/3, I could rewrite that as 4/6. So 4/6 plus 1/6, that's 5/6, still a rational number. So yeah, we're good. All right, the product of two irrational numbers is always irrational. Not always, that's false. Let's say I were to say the square root of 2, which is irrational, multiplied by the square root of 8, which is also irrational. That's going to give me the square root of 16. Oh, but the square root of 16 can simplify because it's a perfect square to 4, which is rational. So that's false. And the product of a rational number and an irrational number is always irrational. This one's also false, guys. Think about our friend 0. 0 is a rational number. 0 multiplied by anything is 0. So if I were to say 0 multiplied by pi, which is our utmost irrational number, we're still going to get 0, which is rational. So yeah, there we go. Let's look at problem 12 now. So it's got parts A, B, C, D, and F, which should be an E. That's okay, just a little typo there. All right, so determine where the numbers below are rational. So I'm going to say, for rational, I'm going to say Q, or irrational, I. Square root of 64, so it says negative square root of 64. That negative throws people off a little bit. But we already know that the square root of 64 is 8, because 8 times 8 is 64. So negative square root of 64 is the same thing as saying negative 8, which is rational. I'm going to put a big Q there. 1/5, that's a fraction. Fractions are ratios, so that's rational. Square root of 20. Although it can simplify, because I can say 4 times 5, so that gives us 2 times the square root of 5, it still is not a perfect square, so this is irrational. Let's look at D. We've got 10 times pi. Anything times pi is irrational. But a big old I there. Then we got 5.2 repeating. So let's think about rationals again. This is anything that can be written as a fraction, that is terminating decimals or repeating decimals. Well, we've got a repeating decimal there, so this is a rational number. All right. Now let's look on to problem 13. It says the length of a rectangle is 3 times the square root of 6, and the width of the rectangle is 4 times the square root of 24. We're going to determine the area of the rectangle. We got to show the work either using the perfect square method or the factor tree method. So granted, you could just plug this into your calculator, but we're not doing that. We can double check ourselves with a calculator at the end though. Area of a rectangle. Area is length times width. And we are already given the length as 3 times square root of 6 and our width as 4 square root of 24. So let's just multiply them together. So our area here is going to equal 3 square root of 6 multiplied by 4 square root of 24. All right, I'm done. Nah, just kidding, guys. Just kidding. All right. So what we're going to do first, when we multiply our radicals, we're multiplying something that has a square root in it, like that. We're going to take the outside terms away. So these are like your coefficients of your radicals. And then we're going to multiply the inside of our radicals, so your radicands, by each other. So I'm going to combine like terms, so pair them together. So in this case, I'm going to have 3 times 4 as my outside value. And then on the inside of my radical, I'm going to have 6 times 24. So I know that 3 times 4 is 12. And then if you don't know it off the top of your head, you can say 6 times 24 in the calculator. That gives me 144 inside my radical. Well, the square root of 144, that's a perfect square because 12 times 12 is 144. So I can now write my radical, the square root of 144, as just 12. So I can say 12 multiplied by 12. And that gives me an area for this rectangle as 144 units squared. All right, we could check ourselves by plugging that into the calculator just to make sure that we did the math right. We had 3 times the square root of 6. And then that was multiplied by 4 times the square root of 24. And that also gives me 144, just like we solved. All right.